In this presentation, we will cover how Particleworks can help you in understanding the temperature distribution inside solid and fluid components of your system. Particleworks allows for different thermal approaches, some that are very fast and others that can be a little bit more computationally demanding. One approach is to evaluate each transfer coefficient from Nusselt correlations and then transfer HTC maps to an external FEA solver like CFX or Mechanical. The second approach, fully integrated in Particleworks, allows for a conjugate heat transfer simulation in which temperature distribution inside oil and fluid can be evaluated, as well as heat fluxes between the phases. In the first approach, Nusselt correlations are used to extract HTC maps as shown in the videos and the images below. This is a very quick approach because it doesn't require additional equations to be solved, as the temperature distribution is actually not computed and no thermal equations are enabled. So we integrate a convective heat transfer coefficient estimation without any temperature dependent parameter. The map is then transferred to the FEA solver for the thermal distribution and the temperature prediction. The second approach, that is a little bit more demanding, is the conjugated transfer approach. We have two different setups, one with a steady state conjugated transfer simulation that is performed after a first MPS only, so moving particles simulation only, simulation. So in this case, we will use the standard solver of Particleworks, the MPS one, to extract the HTC on the walls, and then we will use the finite element solver integrated in Particleworks to extract the temperature distribution from the HTC maps that were previously computed, that are then taken as a boundary condition. This is a very quick approach because it can separate the fluid dynamics to the thermal aspects. There is also the possibility to have a fully coupled simulation with an unsteady conjugated transfer simulation. In this case, the temperature prediction in the oil phase as well as the solid phase are computed in a simulation that is unique, and this allows for the temperature distribution in the fluid to influence the distribution in the solid. Let's have a look to a quick example about that. In this industrial application, a gearbox is analyzed with the unsteady conjugate heat transfer simulation, so with a fully coupled simulation where fluid and solid temperatures depends on each other. The setup is quickly shown here. So we prepare a gearboxes from Comer Industries, and we were able to apply the heat sources on specific elements in red here. So the position where heat sources are likely to be generated in the meshing area and the bearings area. And on the right, we see an example of the MPS, so the moving particle simulation solution with the fluid distribution inside the casing. We would compare two different casing, one as a baseline, as we can see here, without a water jacket that is able to remove some heat from the bottom of the casing. And as you can see, those are the outputs that Particleworks allows to extract. We can have the temperature distribution inside the fluid, as well as the internal solid and the casing. And we can quickly visualize the evolution of the temperature and the evolution from the heat sources that we applied. The second geometry that we will actually test integrates a serpentine at the bottom of the casing with some water injected inside it. So we can see the water heating in the sink at the bottom, and we can also see the effect on the oil temperature that is significantly lower after implementing the serpentine. The same can be seen in the solid temperature distribution. We can clearly see the effect at the bottom of the cooling serpentine, as well as the lower average temperature that we have in the gearbox and in the gears. The casing is also representing at the bottom here with clear lower temperatures for the serpentine configuration. So in this presentation, we discussed a fully integrated conjugated transfer simulation in one digital model using the software, the meshless software, Particleworks. If you are interested to know more about it, please reach us out, and you can find information at particleworkseurope.com.